Hello, I am Snehit and today I am going to present our project Generative AI for cyber threat hunting in 6G embedded IoT networks, and this project was guided by Ms. G. Kirti ma'am. In this project, we focused on building advanced systems that can automatically detect and classify the cyber threats in IoT network in especially 6G technology. We used AI intelligent model, mainly generative adversarial network and transformer to improve our cyber threat detection easy. Project overview. Our project focusing on finding and stopping cyber attacks in IoT systems that runs on 6G networks. 6G network is a buzzword. We are using 5G network currently, and we used generative adversarial network GAN and transformer to make our system smarter. And GAN helps us to create fake attack data to fix the data imbalance in dataset, and transformer that uses the data which is generated by the GAN to detect and classify the attacks more accurately. And we trained and tested our model on Edge-IIoT dataset, which contain 14 different types of cyber attacks such as DDoS and man in the middle MITM and password attacks, etc. Our goal is to make threat detection faster and more accurate and stable for large IoT systems. This diagram shows how our system works. It started by collecting IoT network traffic data, and the data will be pre-processed, which means the unnecessary and noise will be removed from the dataset, and the pre-processed dataset will be sent to the GAN, the Generative Adversarial Network, which contains two parts: generator and discriminator. Discriminator creates the fake attack data and gives to the generator, and generator will detect which it is real or fake. It gone through the so many epochs, and finally generator will create a high quality attack data, which is also called synthetic data. The synthetic data and the given file data will send to the transformer. The transformer will gone through the training and testing process, and then finally the transformer will classify whether it is attack or not. Data flow between modules. Now I am going to explain about how data flows through our system. First, the data is collected from the IoT sensors and devices, and also Edge.IoT dataset also taken and given to the GAN, Generative Adversarial Network, and Generative Adversarial Network will generate the synthetic data, and the both synthetic data and Edge.IoT dataset and the collected dataset is given to the transformer, and then transformer will go through the process training and testing, and the transformer will gives the output, and the output layer says whether the given output is normal or attack, and it is also predict the probabilities of attacks. Technology stack and development. For development, we used programming. Python has our programming language, and machine learning framework has TensorFlows and Skleton-Learn, and Pandas NumPy Pickle has a libraries for handling data and model storage. We used Google Colab for development tool, which is used to run the code, and Firebase has our database and deployment tool, and our model also uses ReLU as a ReLU activation function in hidden layer for better performance, and also softmax activation function in output layer for classification. Mathematical foundation. Behind the scenes, our model works based on key mathematical formulas, and the key mathematical formulas for generative adversarial network is discriminator loss L of D and generator loss L of G. This discriminator loss is used for creating the noise in the dataset, and the generator loss is used to balance the generator and discriminator, and the transformer uses the formula called scale dot product attention to focus on the important data features. And finally, the F1 scores is used to measure how well our model performs, combining with precision and recall for balanced evaluation. This mathematical foundation are what make our model accurate and accurate. This is our cyber threat hunting page. Now I am going to show you our cyber threat hunting page. This is our home page. We have provided some little details about our project, and this is the code of home page, and we have provided a sign up and login button here, and you see this is login button. You have to log in to use our website, and if you not have account, so you have to sign up. This is the dashboard of sign up, and we have code for sign up button. You have to enter email and send emails, and we send a verification to your email. If you have already an account, just go for sign in. Just you have to enter the mail address, and then you have to enter the password. Just click on the sign in, and our threat detection page will appear here, and we have provided an CSV file, and we also, this is code for our threat detection page, and this is max possibility and min possibility. This is our threat detection page, and you have to upload the CSV file to run this code, and you have to select your file, and then it will show now. So processing, it will take few minutes to process, and the processing is completed. You will get 4.41% of possibility. Just this is our code for the model which is run in the background, the transformer model and GAN model, and it will shows the accuracy. This is the graph, shows which attack is going to happen most time. There are so many attacks, and I'm going to discuss about achievements, challenges we faced, and future directions. First, I am discussing about key learnings. We learn how generate GAN synthetic data will help to the transformer, and how to collect the data from IoT device. And our model achieved accuracy up to 56.53 and precision up to 68.89 and F1 scores up to 51.59. And we faced so many challenges, like uh, we face so many challenges like imbalanced data and noisy logs and too many features. And in future, we are planning to use advanced GAN for synthetic data, and also try to use graph based models, and we use real world data sets, and we also have real world applications like smart home devices and industry IoTs, and healthcare systems like patient monitoring devices. And limitations, we crossed so many limitations, like it is hard to detect the rare attacks, so we also detect the rare attacks. And thank you.